Hello friends, we are back. So let's see what all statistics that we can apply here. So let's first of all talk about different concepts. There are three main concepts that you need to figure it out. The first concept is about degree. So what is meant by the degree? Degree. So what is meant by degree? Degree is number of connections that a node has with other nodes. So what is a node here? A node is a country, right? And connections are the borders. So which are the so here degree means how many neighbors this country has with other countries. So that is the degree. So there can be two kinds of degree, in degree and out degree for a directional graph. However, for an unidirectional graph where there is no direction, there is just degree, which is a total degree. The best example of the directional graph is citation networks and airline networks. You have got airlines going from one country to another, but there may be some cases where the airlines don't move to some specific countries, right? So you have got to and fro, or export networks. Export import networks is a very good example of directed graphs. So let's calculate this average degree. So the average degree is 4. That means on an average each country has got 4 neighbors. And let's see the degree distribution here. So this is the degree distribution. On the x-axis it's the value, that means the number of the degree count. So this is 1 degree, 2 degree, 3 degree, 4 degree, 5 degree, 6 degree. This is how many countries has got 1 degree. That means about 17 countries has got a degree of 1. How many countries have a degree of 2? That means about 26 countries have a degree of 2, and most of the countries fall in this tail, right? So we say that on an average however, there are very few countries which have got a degree, very high degree. So this must be probably Russia. So we say that on an average the degree is 4. Okay, so let's go back to the table and see how exactly it gets populated. So as soon as you run the statistics degree, all the degrees gets populated here, and you see here Russia and China, they have got the highest degree, right? So this is that statistics. Now what is this average degree? What does it mean? So average with degree. So before we discuss average weighted degree, we should know what is this weight. What is this weight? So for that we need to go to the edge table, right? So you go to the edge table and you see here there is a weight, right? So what does the weight means? So this weight means that Argentina and Chile, they share a border and the border length is 5150, right? So if you want to calculate the average weighted degree, that means on an average what is the shared border length between the countries. So it comes out to be about 3197, and it says that most of the countries have got an average weighted degree of 3197.9 or 3198. Okay, so let's go to the next matrix, which says network diameter. So now what is diameter? What is diameter in general? So what is diameter? Diameter is the largest or the biggest distance between two farthest points in a circle, right? So in this case it will be the distance between two farthest point right? The shortest distance between two farthest point, and here it is calculated in terms of number of hops. How many hops you need to reach from one point to the another. So let's run it and see, and it says it's 21, right? So when you run network diameter, you will get lot of statistics related to the centrality, closeness, betweenness, harmonic, eccentricity, etc. We'll come to it later. Okay, now the next concept is graph density. Now what is density? So when you run it, you will get these measures how close the network is to complete. So when we talk about the density of a forest, we say how dense it is, right? So how closely packed it is. So how closely packed it is depends upon how many number of edges it has, right? So if a graph is connected to if every node is connected to every other node, you say that graph has got density of 1. But if the graph is not connected to every other node and there's sparse connections, you say the density is low. In this case, we get a density of about 0.026. That means, so it is calculated as E divided by V into V minus 1, where E is the edge and V are the number of vertices. So this is the formula for the directed graph. However, for the indirected graph, the number of edges in the graph is V, but the total possible number of edges can be V into V minus 1, and because this is an indirected graph, we will divide by 2. So this is the density for the indirected graph. Okay, so now let's say what is meant by modularity. So modularity actually divides the entire graph into different clusters. Here the clusters will be divided based upon the number of the neighbors or the connections with the neighbors. So let's see here. So don't change anything and say run. So and you see here the graph. So the graph is divided into different classes based upon the connections with the neighbors, and these are the number of the nodes in each class. Now let's color the graph based upon the modularity. So you go here and say partition and you choose modularity class, okay, and you click apply, and you will see the graph gets colored into different classes or the different clusters based upon the connections with the neighbors. So these are the countries which are connected with each other, and that's how exactly the modularity is calculated. Thanks for listening, and